In this module, we'll turn the digital onboarding and KYC use case into solid architecture inputs. We'll clarify goals, requirements, scope, constraints, assumptions, and risks, so you have one clear baseline that feeds target architecture, compliance mapping, controls, vendor choices, and implementation. You've already built a solid foundation. You learned why eIDAS 2.0 and the EUDI wallet matter, who the main actors are, and how a wallet-based onboarding journey works in principle. We then focused that knowledge on one concrete use case: digital onboarding and KYC, from sign-up through a verified customer profile. From there, we extracted requirements and quality attributes that now become structured inputs for the architecture work that follows. Architecture inputs are the bridge between messy discovery conversations and concrete design decisions. They collect business goals, functional and non-functional requirements, risks, and constraints into a single, agreed baseline. That baseline becomes your reference when choosing patterns, technologies, and controls. If it's weak or incomplete, you risk overbuilding, under-securing, or failing compliance. If it's strong, every design choice is traceable, defensible, and aligned with what the organization actually needs. Architecture starts from a sharp definition of business outcomes. Are you trying to onboard customers faster, cut fraud, shrink manual reviews, or boost regulator confidence? Each goal must be tied to a metric: completion rate, time to onboard, verification pass rate, manual review percentage, or false rejections. Then, surface the trade-offs, like reduced friction versus stronger evidence, and align product, compliance, risk, operations, and technology around the same targets. In this use case, scope means everything needed to take a new customer from wallet presentation through a complete KYC decision. We include the user's EUDI wallet sharing attributes, the relying party generating requests, and the verifier validating trust chains and signatures. We also include creating the customer profile, logging evidence, and routing edge cases to review queues. Across all of this, our architecture must address security, privacy, observability, scalability, and evidence retention. Architecture work always needs a clean edge. Here, the edge is that we focus only on onboarding interactions, not the whole identity or wallet ecosystem. So there's no full wallet issuance design, no country-by-country wallet variations, and no AML transaction monitoring workflows. We also deliberately park richer journeys like recovery, credential issuance, and multi-product onboarding. Naming these upfront protects the design from scope creep and creates a clear backlog for later phases. Every architecture choice should answer a clear requirement. Functional needs like credential requests, verification, KYC decisions, and profile creation drive which capabilities we design and how they interact. Non-functional needs such as resilience, privacy, auditability, and maintainability shape qualities like redundancy, logging, and data handling. For each requirement, we link it to a component, call out any open questions, and keep that trace. Later, this same trace becomes the backbone for compliance and control mapping. When you design a wallet-based KYC onboarding flow, you're never starting from a blank canvas. Regulation dictates what evidence you can collect, how you store it, and which assurance levels are acceptable. The wider ecosystem sets how fast you can move, based on wallet availability and cross-border readiness. Your existing platforms and chosen vendors further narrow your options. Good architects make these constraints explicit, then optimize the design within that boundary. Wallet-based onboarding only works if the surrounding ecosystem is ready. You need enough users with an EUDI wallet to make the journey worthwhile. Verifier services must reliably handle presentations, validate credentials, and support your chosen protocols. You'll often still rely on KYC and AML partners for sanctions checks, PEP screening, risk scoring, and manual review. Finally, trust registries and status services underpin your overall verification confidence and risk posture. Assumptions are guesses we're temporarily treating as true. The danger comes when those guesses quietly harden into architecture decisions. To avoid that, treat each assumption like a small experiment. Write it clearly, tag what it affects, assign an owner, and record how confident you are. Define how you'll validate it and by when. If it's still unproven, it belongs in your risk register and your proof of concept plan, not in your list of confirmed decisions. To keep things concrete, we'll anchor the reference architecture on 4 working assumptions. First, your customers can present credentials using an EUDI wallet, so we focus on wallet-based flows, not document uploads. Second, the relying party can join a trusted eIDAS 2.0 ecosystem, so governance and trust lists already exist. Third, Azure is the target cloud, which drives our service choices. And fourth, key backend APIs for profiles, KYC, cases, and audit logs are available. The verifier is essentially your policy engine for trusting credentials, so the sourcing model strongly shapes your architecture. A managed verifier gives speed and package compliance, but you inherit the vendor's roadmap, SLAs, and data paths. Building it yourself maximizes control and flexibility, yet demands strong protocol, security, and audit expertise. A hybrid model splits orchestration, trust checks, and business rules, letting you balance agility against ownership and operational burden. An initial risk register is your early warning system. You're not predicting the future. You're making uncertainty explicit and actionable. In this module, we're capturing 4 big themes: regulation, interoperability, vendors, and users. Each risk gets a clear description, impact, likelihood, and an owner accountable for mitigation. The key is discipline. Write risks down, review them regularly, and tie them directly to actions. If it isn't in the register, it usually doesn't get managed. Architecture inputs only matter if they change what we design. Start by scoring each risk for likelihood and impact. High-risk items trigger concrete actions: proof of concept tests, vendor due diligence, and explicit design decisions. Turn critical assumptions into validation tasks, not wishful thinking. Then design fallbacks for wallet outages, verification failures, and unsupported credentials. Finally, feed any remaining risks into your compliance mapping, control matrix, and roadmap, so every risk has an owner and a visible decision. You've now built a complete architecture input pack: clear goals, scoped requirements, explicit constraints and dependencies, plus documented assumptions and risks. Together, these bridge business discovery and solution design. Next, we'll turn this pack into regulatory themes: GDPR privacy by design mappings, AML and KYC evidence, and a concrete compliance to control matrix.